Analog lab. So this is going to be a fun lab. We're going to combine some concepts we've been doing over the last couple of weeks. And the part that we're going to talk about today is going to be the photocell. So you guys have used a photocell before. I asked you to use one in week 1. And basically, it's a light-sensitive resistor. The more light you shine on them, the less resistance you have. The darker they are, the more resistance they have. So what I want you to do is take out a resistor from your parts kit. Usually we'd all be getting these from the same place, probably from SparkFun. But since we're going to be like dealing with photocells from all different places, we're going to have to really measure them to know what our min and max values are. So what we're going to do is use the resistance setting on the multimeter. And I'm just going to switch over to my desktop cam for a second. And what I'm going to do is, I'll slide you over because we're not going to get into it yet. I'm going to take the probes of my multimeter, and I'm just going to kind of wrap these photocell legs around these probes so that I can kind of like see what's going on here, right? So the first thing I'm going to do is I'm going to set my multimeter to kind of a low measurement. I'm going to do like 2,000 ohms, and I'm going to use the, you can see I'm sitting at probably around 2,000 ohms. You can't really see because this is glare, but 1975. So that's ohms. Let's see by shining light how low I can get this to go. I'm just going to use the flashlight on my phone. And I'll slide that out of the glare so we can actually read it. So, all right, let's see. So I'm going to point this flashlight kind of directly at this. And I'm going to get it down to, looks like 285, 260, 250. 230. Let's say 230 is maybe the min. I kind of saw it dip below that. Maybe if I move this closer. All right, 230 seems to be, oh wait, 189. All right, so I guess depending on how close I can get this. 144. Okay, let's do 144. We're probably not going to get much lower than that. So I'm going to say min 144. And now let's see what we can get our max. So for the max, I'm going to crank this up a little bit higher. I'm going to go to 200,000. And it's worth noting, like, this is now in the 100,000 range. So this is like 200,000, right? Or just, sorry, 2,000. This decimal place is the 1,000. So if I cover this up, let's see how far I can get it. 56,000, 103,000. Even if I just like cover this with my finger. Doesn't look like I'm going to get it much above 100, right? Oh, whoa. So 160. As you can see, it's pretty unstable. It seems like 100,000 is maybe as high as I can get it. Yeah, a little bit more. 120? Let's do 120. 120K seems like a good... So 120K. And so these are the values I'm going to be working with. Now, whatever you measure are going to be your photocell values, right? So this is 144 ohms, is 120K ohms, right? These numbers are going to be important because we're going to be building circuits and we're going to want to match the min and max values of our photocell. So I'm just going to kind of straighten these legs back out because I'm going to want to put it back in the breadboard. But now I know the max value for this is going to be 120K, and the min value is going to be 144. All right, so now that I know that, let's head back to the lab. So Put the probes on the photocell so you're measuring the resistance. Point the flat side of the photocell up toward a light without shadows on it. Write down the resistance. Next, cover the photocell with something and measure the resistance in total darkness. So, you know, you're probably not going to have values close to mine. This is going to be a little arbitrary because the values fluctuate so much. So it's not important that you really pin down an exact number for this, but we want to know what the range is for our photocell, right? I know that the min value is somewhere between 100 and 200 ohms. The max value is somewhere between 100K and maybe 150K. The exact numbers don't really matter, but we're going to want to know kind of where the photocell falls. So let's do some experiments. The first thing we're going to do is we're going to use the photocell in place of the pot or resistor in an inverting or non-inverting amplifier. So in week 5, we built some amplifiers where we adjusted the wave shape using a potentiometer. So what I'm going to do here is I'm going to make an inverting op amp, and I'm going to talk about this while I look at the schematic. I'm going to set my R in, and I'm going to read this too. RF is the photocell, right, the feedback resistor, and Rin is going to be a regular resistor at around the value of your photocell's max resistance. So remember, gain is negative RF divided by Rin. That means the max resistance, when it's at its darkest, is going to be a gain of 1, right? This divided by this, if they're the same max resistance, it'll be 1. However, as I shine light on it, RF gets smaller. And so I get basically a fraction of gain, right? I can go down to like 1/2, I can go down to 3/4, I can go pretty much all of these percentages of my gain of 1. And why is this useful? Well, if I wanted to build an inverting amplifier that attenuates my volume, this is how I would do it. And this is a little bit of foreshadowing into how we might build a tremolo, right? We're going to have a max gain of 1 and a minimum gain of pretty close to 0. We're not going to actually get to 0 because my minimum value is 144, but it's going to be pretty close. So the other thing is, you know, your amplifier is only going to attenuate and you won't accidentally risk blasting your drums, right? So that's the other good reason to do this. So let's build this circuit, and I'm curious to see kind of how this looks, right? And I know we did this if you did the bonus before. So I already have some things set up here on my breadboard. I've got my DC blocking circuit up here. I've got actually 2 op amps, and I'll tell you why I'm doing that in a little bit. And I've got my little battery clips down here, right? And so what I'm doing here is I'm running my -9 into this bottom op amp and then daisy chaining that so that both of these op amps are getting -9. I've got ground in my negative rail, and I've got my negatives connected together, just like I did last week, right, with the black wire. And here's my +9. I'll actually just move that up a little bit so we can see where that plugs in. I'm just going to plug it into the right-hand side because, as you know, we're going to power both of these op amps. And so let me just plug in the top one here. We're going to do pin 8 to power, just like we've been doing. And I can also do this with the bottom op amp. Let me find a shorter cable. And even though we're not using this bottom op amp, I'm just going to make sure everything's powered up so that I don't forget to do it later, right? So basically, I've got my power, my +9 over here. I've got my -9, which I'm not plugging into the side rails because I don't want to get confused about that. So I'm just going to plug it into the bottom and daisy chain it up to the top, right? So remember, I'm not plugging in batteries just yet. I want to make sure everything's wired up so I don't mess anything up with power plugged in. Okay, so we're going to build a non-inverting op amp. So let's just, we're building an inverted op amp, which means I'm going to be going through my Rin into the inverted input. Now, if you're still not comfortable with the pins, I might recommend pulling up a data sheet. I've got a max resistance of 120K. And I think maybe the closest resistor I have is going to be a 100K. So I'm going to use that for my R in. And the gain will go a little bit over 1, because it'll be a 120K divided by 100K. But it's not going to be that much amplification. So I think this will work well for my case. You know, the next resistor up is going to be way too big. So I want to be able to hear this signal. So what I'm going to do, because I didn't touch my DC blocking circuit, I have my resistor and my capacitor here. Let's just make sure that we're going in the right direction. I think I actually have this in reverse. All right. Then I'm going to go with my 100K into the inverting input. Now remember, if I'm using the left-hand side here, I'm going to go from my capacitor, from my DC blocking, into pin 2, which is my inverting input. And my photocell is going to be in the feedback loop, which is going to go from the output to pin 2. And it doesn't like these holes because it was just curled up. And these photocell legs are really long, so I just want to make sure that they're not touching each other or it's going to short to itself, and also that nothing else on here is being shorted. My capacitor, when I moved it, actually popped out, so I'm going to put that back in here. Okay. And I have to remember that in this circuit, my pin 3, my non-inverting input, if I look over here, is grounded. So I want to make sure that I do that over here too. So I'm going to plug pin 3 into ground. Okay. Now, before I do anything, I have a DC blocking on the output, but I just want to make sure this is going to work. So before I even do that, let's just take a look on an oscilloscope and make sure this does what I think it's going to do. So I'm going to slide this over. We're going to bring my oscilloscope into frame. And I'm going to grab the probes. All right. Plug the black probe into ground. And I'm going to plug the red probe just into pin 1 into my output. Okay. And let's just bring this up a little bit so we can see everything. So, this audio jack is pretty bad, so I'm just going to make sure it stays in there. And just so I can get this working correctly, let's just pump in a sine wave. And we'll see if it works. So there's my sine wave. I've got it on the oscilloscope. Now let's see if this works. Oh, right. I don't have batteries plugged in. Rookie mistake. There's one. And there's the other. All right, so you can kind of see I might have to crank up the volume on my phone a little bit. As I cover this, the gain goes up. See that? And it's not divided so much. I'm kind of gonna. So right, at max resistance, right, I should be seeing my full signal. So let's see, I'm using 0.1 right now. And what I want to do maybe is just see what this looks like coming in. So I'm just going to move my oscilloscope probe down to the input here. And So it's pretty big. It's a pretty big signal. Let me just kind of move it around a little bit. So looking at this, this is about a little bit over a 1 volt wave. So my oscilloscope is set to 1 volt here, X1 here, and it's about 1 block up, 1 block down. Let's see if I can lock my phone so it does not turn off. And so basically, if I go back to the output, what I'm getting here is really kind of a fraction of what I was seeing, right? Oh, and I lost my audio jack. That doesn't help. So it's really hard for me to even get close to what my input signal was using this resistor, right? Which is fine. This is what I want to happen, right? I want this to be attenuated, and I want this amplitude to increase as I cover this. If I wanted to see more of this wave, I could actually decrease this resistor, right? It's 100K. If I use something like a 50K, I would see a much bigger signal gain. But what's happening now is this signal is kind of attenuating as I'm changing this. So now, let me actually set this up with music and see what this looks like, right? So I'm gonna just get rid of my oscilloscope. I'm gonna toss it over there for a minute. And I'm gonna set this up with an output jack. And so what I'm going to do is I'm going to grab a 220 ohm resistor and a 10 microfarad capacitor. I'm going to come out of pin 1 here. All right. And we're going to go into here. And I've still got this kind of loose audio jack, so I'm going to use this for my output. Realizing I left my speaker in the other room, so let me grab that, and then we'll hear how this sounds. Okay, so I've got my speaker. It's just going to be a little bit off screen, and I'm going to plug it into here. And let's turn off Bluetooth so I don't accidentally connect to it via Bluetooth. And let's see if I can get this working. So you can see, right? I can barely hear it when I'm shining light on this photocell. But if I start to cover it up, volume goes up, right? So you can imagine this is kind of how a tremolo works, right? I'm just changing the resistance on this inverting amplifier. So, let's switch back. So basically what I'd like you to do is use your min and max photocell resistance values to build this and get it working. I'd like to see this working on the scope. And then if you're able to, listen to it on speakers or on headphones and confirm that you're able to get the volume to increase and decrease. Okay? So that's part one. So now let's think about another circuit. Let's go back to the oscillator from last week. And let's use the photocell to control the pitch of the oscillator. So, first things first. I'm going to pull the photocell out of this circuit, but I'm going to leave this circuit alone. I'm going to disconnect my batteries because I don't want to accidentally fry anything while I'm doing this. And then I'm going to get rid of this output because the oscillator... actually, I will use this output, but I'm going to move it all the way down here because I'm going to use the second chip to build this oscillator. So let me get rid of my DC blocking circuit. I'm just going to put it on the side here because I'm going to rebuild my oscillator on this chip. If you left your oscillator intact, you can use it for this circuit. A lot of you are building synthesizers, so now is a good opportunity to rebuild this whole oscillator circuit. So let's pull up last week's lab. I'm just going to bring up a new window. And we'll look at this circuit. Seven. And here's our oscillator circuit. So, let's just start by grounding the pins that need to be grounded. I've already got my power plugged in. So I'm going to ground the inverting input on the left-hand side and the non-inverting input on the right-hand side. So, take black wire. I might be running out of black wire, so I think I'm going to start using gray and brown to represent ground. So we're going to ground the inverting input, which is pin 2 on this side. And we're going to ground the non-inverting input on the right-hand side, which is pin 5. Okay. And then I'm going to just do what I did last week, which is start at the left-hand side and just work my way to the right. So I'm going to start with the non-inverting input, and that's going to go to 2 resistors. I've got a 10K and a 1K. So I've got my 10K going from the output to pin 3, the non-inverting input. And I've got a 1K going from pin 3 all the way around to the output of the other side, which is pin 7. This is my feedback resistor. Being careful that the legs are not touching. Okay. Then I'm going to do my square wave voltage divider at the top, which is a 10K to the output. And what I'm going to do for this one is, well, I don't really care about the switch right now. I just want to see that the frequency is being adjusted. So I'm going to build this voltage divider, but I'm just going to look at the square wave today, because I don't really care about the triangle wave. I just want to see the square. So I'll take a 10K, and that will go from the output down to another row down here. Okay, just making sure that I don't touch too many things. And then I'm going to split this with a 1K to ground. This will just make that volume significantly lower, because that's going to be a 9-volt signal. And then, from here, I'm going to go into my DC blocking circuit. I don't care about the triangle wave so much, so I'm going to take the switch part out. And so we'll go capacitor, resistor, into the output jack. So, got my output hooked up. Now, I'm going to use the Photocell for the middle. And I'm just going to use this for all of R sub t, because I remember I had the 1K here just as a buffer, because if I turn the 100K all the way down to 0, I wanted to make sure I still had some resistance. I still had 1K. So if you want, you can play with this, but I know that my Photocell is going between 150 ohms on the low end and 120K on the high end. So it's going to be even bigger than this range. So if I use my Photocell to go from the output of the first op amp to the inverting input, it should give me almost the same range. Now, this resistance is going to be smaller, so it might be a little more ear-piercing, but we'll see what happens. So we're going to go from the output of this over to the non-inverting input, which is pin 6. Again, it's getting a little crowded here. So once I plug these guys in, I can just kind of make sure that nothing's touching. Got to be careful of shorts in this kind of situation because we've got a lot of stuff in here. You could bend the legs as you need just to make sure everything is fitting. You can also even trim these so they're a little bit shorter. I know some people like their resistors to be flush with the breadboard, and that's also an option. Cool, so I took care of RT, and now all I need is the capacitor. So I'm going to get myself a 1 microfarad capacitor, and we'll throw that in the feedback loop. You're 100. I want you. Let's see. All 10s. Here's the 1. Right, so I accidentally put that in place of the 10. Make sure you read your capacitors first. So my DC blocking capacitor was my 1. I'm going to put the 10 in there. And now this guy can go in my feedback loop from pin 7 to pin 6. And that should be the last thing we get there. Okay, so let's plug in my batteries and we'll cross our fingers that this is going to work. And we're not getting anything. Let's see. Got a little bit of a short. Okay, that's really annoying, but it works. So let's take a look at what's happening on the oscilloscope. I'm just going to take this DC blocking circuit out because I don't need it, and pop in the probes into where my square wave is. And let's just move this over here. You can kind of see, I'll make this a little bit bigger. So I've got my frequency here. As I make my photocell darker, my frequency gets lower, right? So you can use this photocell in place of a potentiometer, right? In a lot of different places. And you might be thinking like, wow, this sounds like a theremin. You are right. This isn't a true theremin, but if you did want to use light to control pitch, this is exactly what you can do. And I know a lot of people will want to build their final project with like 8 photocells controlling 8 oscillators, and that's totally fine. It gets really crazy, and that might be what you're into. So I want you to kind of think about interfaces, right? I'm going to get into finals in a little bit, but you can start thinking about your final in terms of what you're actually using to control the project. Are you turning knobs? Are you flipping switches? Are you pressing buttons? Are you waving your hands in front of photocells? There's a lot of different interactions that you can have with your final project, and there are almost as many options for resistors. There's resistors that you can bend. There are resistors that you can slide your finger across to change the resistance. There's slide potentiometers, which you're all probably familiar with on like a mixer. There's all kinds of different ways to use resistors. So this is only one of the ways, right? So I'm going to go back to Lab 8. For the second part of this, I want you to do exactly what I just did. Build the oscillator and use the photocell to control the pitch. I want to see a video of the oscilloscope, and I want to see a video of you actually hearing it on headphones or on speakers. I know some of you have been having problems because you might not have a way to get sound out, so let me know if that's a problem. But this is probably the biggest bang for your buck in terms of, like, this is a cool thing to build, because now you've got an oscillator that you can change just by, like, waving your hands in front of it. So these are the two mandatory parts of this week's assignment. However, I'm going to get into some optional stuff because this is where it really gets fun. So we're going to make a tremolo. And here's what we're going to do. I'm going to leave both of these circuits together. I'm going to pop the photocell back into the first circuit, the inverting amp. So take this guy out. And we're going to go back from pin 1 to pin 2 of this circuit. And what I'm also going to do is kind of bend this photocell. If I can get it into the breadboard. These holes are pretty unforgiving. Going in. All right. Yeah, I'm just going to bend it this way, and I'll show you why I'm going to do that in a second. Although being careful not to touch wires with anything, right? Okay. Then I'm going to go back to my oscillator down here, and I'm going to just plug in my my potentiometer from last week and my 1K. So this is going to go between the output of the first op amp and the inverting input of the second one. Let's see, do I have a 1K I can use for this? I'm going to use a 10K, which just means my pitch isn't going to be as high. This is going to go from pin 6 down to this potentiometer. Cool. And then I'm going to use a wire to get from this potentiometer back up to pin 1. And after I do this, let me just verify that this works, because I just messed up a bunch of stuff, so I want to make sure that I still have a square wave here. Yeah, this wire is a little messed up. Let's put it over there. Okay. Cool, so I've got a square wave, right? I'm just going to verify that this thing still works. Cool. All right. Now, the other thing I'm going to do is I'm going to take my capacitor. This is a 1 microfarad capacitor, and I'm actually going to, well, let's hold off. I'm going to make this other part first. So what we're going to do is we're going to plug our oscillator into an LED. What we want to make happen is we want an LED to be blinking with the oscillator. And what we're going to use is this circuit. What this is it's sort of a buffer with an LED in the feedback loop. And I have 2 LEDs here, but this is just to show you that when the square wave is positive, it's going to light one of these LEDs. When it's negative, it's going to light the other, right? Because we have a high potential and a low potential. So the output is either going to be high or low. So these 2 LEDs are actually going to alternate being on. I'm only going to use one, and I'm going to need another op amp. So let's take a look. I use both sides of this. This is my oscillator. I've used the left side of this for my inverting amp. So I still have an op amp over here. So what I'm going to do is I'm going to use pins 5, 6, and 7 on this side. So we're going to go from the oscillator input, which is way down here, through a 1K into the inverting input all the way up here. And I'm just going to get my 1K, and I'm going to go from the inverted input into just another row down here. And then I'll just grab a pretty long wire because my oscillator output, which I'm going to unplug the oscilloscope, is all the way down here, and I need it to get all the way up here. And then I also need to ground the non-inverting input. So I'm going to do that, which is pin 5. Okay, now let's just double check. Now with my oscilloscope, I should have my oscillator up there, which I do. So that's good. Now let's pop in an LED. Now what's nice about this is this LED needs to go in the feedback loop from pin 6 to pin 7. But it doesn't really matter the orientation, right? Because in one orientation, it will light up on the positive side of the wave, and on the other, it will light up on the negative side of the wave. All right, so I've got an LED. Let's focus this, come on. And it seems to just be on. Let's see if I can get it to even slow down. Okay, so I've got it to kind of slow down, but it's still really, really fast. And what I can do now is, remember our equation for an oscillator where the R and the C were in the denominator? If I change the C, this is 1 microfarad. If I make this significantly bigger, like if I make this, oh, this is 100, that's way too big. Let's make it 10. If I pop in a 10 microfarad for this, I should be able to slow down this blinking into what's called a low frequency oscillator, or an LFO. If any of you are synthesizer aficionados, you might be familiar with the concept of an LFO. It just means we're going to use this as a clock rather than as an audible frequency, right? So now if I look at this, this wave is moving way too slow for even this to clock. I'm going to have to actually probably change my timing. Yeah, so this is going to be, this is 1 second. And I'm getting some kind of weird artifacts here, and this might be a result of the capacitor. But that's okay, you know, because I'm not actually listening to this oscillator. All I care about is that this LED lights up, right? So All right, I've got an LED lit up. I'm going to unplug my oscilloscope. And what I'm going to do is I'm going to point this LED at this photocell. Now, this concept is known as a Vactrol. And if you want, you can tape these two up in a plastic tube or a straw. You can wrap them in electrical tape or heat shrink. And this LED and photocell together are going to change whatever the photocell is plugged into. In this case, it's going to be the volume of this inverting amplifier. And what we're going to listen to is the output of this inverting amplifier with it being modulated by this LED. Now, what I want to kind of point out here is the audio is only running through this circuit, right? This is the whole thing. The only thing is the photocell is being affected by the LED. So I should hear a tremolo. I had to build this whole complicated oscillator circuit with this LED in order to make this pulse at a regular interval, right? But my input and output, this is a pretty simple circuit, right? So let's see if I can make this happen. I'm going to come out of this with my DC blocking circuit. So it's getting a little crowded here. I'm going to come out of my output. Let's actually we'll use a big wire here. I'm going to get a big red wire to come out of the output. I'm going to go down to the bottom of my breadboard where I got some room. And we'll go from my resistor into my capacitor. Use another 10 microfarad capacitor. And where's my speaker? Ground it. We'll plug in the output. And let's see how this sounds. Now I can adjust the speed as well. Now, the reason that I was covering this with my hand is because the light that I'm using to light this breadboard is actually affecting the photocell, right? So the more I can cover this, the more the photocell is just affected by the LED and not by any other ambient light. This is why it's a good idea to have a straw or something to kind of like cover these two together. So that's all tremolo is, right? What we're doing is we're building essentially 3 circuits. We have our oscillator circuit, and all I did here is I changed the capacitor. I changed it from a 1 microfarad to a 10 microfarad just to shift the entire frequency down to a low frequency oscillator. Then I took the output of that and I ran it into what's essentially a buffered LED circuit, so that the LED wasn't affected by the voltage, it just got turned on or off, depending on the square wave pulse, right? And then I took my audio and I just ran it through a regular old inverting op amp. This determines the gain based on my photocell, and the RN that I measured at the beginning of this class. And because the LED is pulsing at a regular interval, I can see, or I can hear even, the volume go up and down based on that interval, right? So this is a bonus, but I would encourage you to build this because this is a really interesting circuit for this class. Vactrols can be used in a lot of different ways. These days, this whole thing is in chip form, so, you know, they've been able to kind of simplify the whole photocell LED relationship. But back when guitar pedals and effects pedals were first being built, you would see a lot of these inside of old guitar pedals. This is how tremolo was originally made. So, you know, I would encourage you to try the tremolo if you want to even do something a little more complicated. You can make a vibrato, which is, I'm not going to build this, but you can build a second oscillator, and you can use the LED to control the pitch of the second oscillator. So you have one oscillator, that's your low frequency clock. You have your second oscillator. You're going to need another chip, a third chip, because you have to run that LED buffer in order to point at the photocell. But if you have enough op amps and you really want a challenge, you can make this vibrato. And I'll give you an extra bonus point for each of these if you can get them working. So I want you to at least attempt them. I think the tremolo is a good part of a final project, especially if you're thinking about an effects pedal. If you're a guitar player, this is something that is really handy. Even just making a clock that can affect another effect is a useful thing. And you can do this for filters, you can do this for phasers, all sorts of different things. So, you know, your oscillator can be an audible oscillator like we made last week. It can be a clock like we're making this week. So that's it for you know, the physical build of this class. And what I want to spend the rest of this time on is the final project. This one is not optional. You must do this. So in office hours, we are going to be talking about final projects. So I want you to make some decisions. I've already talked to a lot of you about what you want to make. I've asked you to decide if you want to make something that generates audio or if you want to make something that affects audio. What I want you to do this week is write one long paragraph explaining what your final project is. Draw a diagram that explains how you interact with it and what the inputs and outputs are. I want you to start making a parts list and note which ones you have and which ones you'll need to buy. So there's a lot here, and I want to just talk about this one by one. You will tell me what your final project is. If you have two or more totally different ideas, you can talk to me and I'll help you decide on one, or you can do this exercise for both. If you're thinking of doing something that's way beyond the material covered in class, please send me an email so we can talk about it. I've spoken to some of you that want to do a little bit more advanced projects, but if we haven't covered it yet, please talk to me as soon as possible. Do not send me this email the night before we talk. I want to get ahead of any additional work that you might be putting onto yourself, because some things are very, very complicated. So I'm going to approve or not approve extra work, right? I would like you to think about the concepts we're covering and try to form a final project out of the things we are already doing. Gain, filters, oscillators, you know, combine these things together. We're going to do distortion next week. If you are wondering about something, please talk to me first, and we'll see if it's feasible. Your diagram doesn't have to be an engineering diagram. I am wondering how this project works. Is it a guitar pedal? Is it a synthesizer? Do you press buttons? Do you turn knobs? Pretty much what I was talking about earlier. Figure out your interface. What are the inputs and outputs? Are you plugging in a guitar cable? Are you plugging in a microphone? everything we've been doing, we've been using 1/8" headphone jacks. So if you want to use a guitar, you're going to have to either get an adapter or figure out a way to plug a guitar into your breadboard. If you would like to use a microphone, you'll probably need a transformer, right? You'll need to change it from low impedance to high impedance. They have those, if you've ever plugged a microphone into a guitar pedal, they're like a long cylindrical thing. So we can talk about that. Are you building something that affects line level audio signal? Like you're going to plug your computer into it and just play music. Does the thing generate its own audio? Is it an oscillator? Is it a combination of oscillators? Some of you would like to build a polyphonic synthesizer. It's totally fine, but look, this is just 2 op amps on a breadboard. So, you know, here's an oscillator. You're going to have to be building that for each note in your polyphony. So I want to kind of rein in your projects this week and figure out what you all are making. This is going to be probably one of the, I guess, most important office hours because I want to set you on a trajectory for success for your final project. So, you know, please come prepared. I'm going to ask you what your final project is this week, and I would like you to know what that is. So if you haven't made up your mind, just start thinking about it so we can talk about it. Okay? And that is it for this lab. We're on the other side of midterms, so the final is really the last thing. Yeah, hopefully this is a fun lab, and you all have fun making a tremolo, and I look forward to speaking to you in office hours. Okay? See ya.